Okay, hi everybody. I'm just going to work a couple problems here in section 9.2 again. This is the distribution of sample means, and this is the proportion part. Okay, so and we know it's the proportion part because we see that it has a mean of 5%. Okay, the other thing that's going to give away that this is a proportion problem is that in proportion problems you don't get a standard deviation. It's not listed in the problem at all, and that's one of the clues because in proportion problems, you calculate the standard deviation in the problem itself. Okay, and I'll show you what I'm talking about here. So it says, assume that 5% of students at a school reach the finals of a dance competition. So 5% is actually your mean. What are the mean and the standard deviation of the sampling distribution of students? You have a sample size of 150. So basically what they just want is the mean and the standard deviation, okay, for this problem. So if we go to paint here, the mean mu of P will be equal to, it was 5%, so that's 0.05, okay? Now the standard deviation will be the square root of P times 1 minus P all over N. Okay, so let's see, what was our sample size for this problem? 150 sample size. Okay, so this is going to give us the square root of 0.05 times 1 minus 0.05, okay, divided by 150. Okay, so if we go to our calculator here, we can type this in. Let me do it down here. Well, maybe not. Let me just do it right here. The square root of, and I'm going to use parentheses for the numerator, 0.05 times 1 minus 0.05, close parentheses for the numerator, divided by 150. Okay. So 0.017, let's call it 8.018. Okay, 0.018. So if we go back to the problem, correct answer 0.05, standard deviation 0.018. Okay. All right, let's look at one more. Okay. In this problem, it says a recent survey data. It is known that the proportion of adults in the United States who are smokers is 35%. So that's your mean. For a random sample of size 150, what is the probability that the proportion of smokers will be less than 25%? Round your answer to 3 decimal places. Okay. So I'm going to come back here. Let's see. I'm going to draw a line here. So this is our next problem. So in problem number 2, we know that mu sub p is going to be equal to 35%, so 0.35. Okay. And we'll calculate the standard deviation here in a minute. We know that n in this problem will be 150. Okay. And the question is asking for less than 25%. Okay. So we're trying to answer the question, what is the probability that x is less than 25%? Okay. So, the first thing that we have to do here, remember how your standard deviation is calculated. The standard deviation of P will be equal to, in this case, the square root of 0.35 times 1 minus 0.35, all divided by 150. Okay. Now, this problem, if we draw it out, in the middle here, we've got 0.35. That's your mean. And we're doing less than 25%, which is going to be over here, 0.25, 25%. And for less than, remember we shade in this direction. Okay, so that's what we're looking for. What's the probability of landing in that area? Now, this again is just a normal distribution problem. So we can go right to our calculator. Again, we're going to do second distribution, normal CDF. Our lower bound here is negative infinity. Okay, and if you remember from chapter 8, negative infinity, we can just do negative 9999999. Okay, just a bunch of nines, and that'll suffice for infinity. Okay, but negative infinity. The upper bound here is going to be 0.25. The standard deviation, or excuse me, the mean in this case is 0.35. And you can carefully enter your standard deviation right here. You don't really have to calculate it beforehand. So I'm going to do parentheses for the numerator. 0.35 times 1 minus 0.35. Okay, close for the numerator, divided by 150. And then close for the whole thing, because I believe this one started off with a parentheses. I do believe in the beginning. Let's see. Yeah, it opens with a parentheses. So we're going to go down to paste. Oh my goodness. It's stuck here just for a second. Give it a minute. All right, there we go. And hit enter. So 0.005. Okay, 0.005. Or as a probability, this would be 0.5%. Okay, let's look at the problem. And there we go. Correct answer, 0.005. Okay. And here's some instructions on how they work through it down here. So pretty simple once you kind of figure out what you're doing. If you're having trouble, if you're getting weird answers or you're not getting what I'm getting, you might do the standard deviation before you go to the calculator. For example, make this easier to type in. I know that this is 0.35 times 1 minus that amount. Well, you don't have to do 1 minus that amount like this. You could just type in, I know that 1 minus 0.35 is 0.65. Okay, so sometimes that can make the problem a little bit easier, and just divide by 150. And go ahead and figure that out before you type it into the calculator. So if I wanted to, I could just do the square root of, the square root of, parentheses from a numerator, 0.35 times 0.65, close numerator, divided by 150. And I could just write that down. Let's say 0.398 or 389, I believe it was. Okay. And then when we go to do our normal CDF, instead of having all this mess right here, which is fine, but instead of having all that, I could just put 0.389. It makes it a little simpler to put it in the calculator. And as you'll see, let's see what happened here. Oh, I forgot a zero. There's a zero at the beginning here. Okay. So right here, decimal point actually goes here. Sorry, let me erase that little decimal point right there. Okay, so 0.0389. So let's go back to our distribution here. Okay, so negative infinity. Did I go to the right one? Let's see. Second distribution, normal CDF. Yep. Okay. So let's clear that out. Negative infinity. Okay. Bunch of nines. Upper bound is 0.25. Mu is 0.35. And the standard deviation that we calculated by hand was 0.0389. Okay. And as you can see, we still get the same answer. Okay. So either way you want to do it is fine. All right. Well, I hope this helped. And if you have any other questions, uh, don't feel free to email me or get in touch with me any way you can. There, you can call my office phone. It directs to my cell phone. So everybody stay healthy, and we'll talk to you later.